thank you so much for coming. I'm really gratified to see so many people here. That's really great, people who want to explore Vic and explore what it can do. I promised to give you a bunch of demos today, and that's exactly what I'm going to do. I'm going to spend most of my time, almost all of my time, in live demos. I don't know if you guys saw the DockerCon thing where they touched some horns to appease the demo gods. I have no such way of appeasing them. But I will be talking over my VPN to a cluster of Mac Minis running ESX and vSphere on my desk in San Francisco. So we'll see how that goes, okay? I do have some backups. But yeah, we're basically just going to spend this whole time in demos. Why are we doing that? Because sure, I could talk for a whole hour about what Vic is and what it does, and there's a huge amount of value in that. But I really like seeing something work, and seeing something, being inspired by how it can be useful and the kinds of things that it can do. The other thing I'm going to be doing is previewing Vic 1.2, which is, there's a release candidate out, and it's about 2 weeks away from being GA. It'll GA before VMworld Barcelona, or maybe at VMworld Barcelona, around that time. So giving you a sneak peek of what we're doing and where we're going. So I'm actually going to get straight out of the presentation. We'll get back into the presentation in a second. So let's just start by looking at my environment. So I have this, fortunately I have the ability to zoom. I have this cluster of Mac Minis, and I have the Vic OVA installed to that cluster. Now, in terms of storage, I have vSAN data store, and I have iSCSI data store. We're going to explore this a little bit more in a second, but that's my basic cluster. And what I'm going to do is I'm going to install a virtual container host to that cluster. Now, I'm going to do it and then tell you what it is. Interesting. All right. So I'm going to type Vic machine, which is our way of installing a virtual container host. Now, those of you that have used Vic machine, you'll see there's something a little bit different about what I'm doing here. I'm taking our master branch, and I'm going to install a configuration that I'm calling devcert, and then I'm going to call create. So that's now going to go off and run Vic machine and install it to this virtual container host. Now you'll see the output that it's giving here. It's basically checking the firewall status, it's checking the networks. But what is a virtual container host, this thing that I'm installing? Well, I would do this as an admin. This is my way of delegating an endpoint for a tenant to use into my vSphere cluster that they can consume with the Docker client. So this is an admin task. In order to do this, I need vSphere credentials to be able to install the virtual container host. You'll see in the background here, it has installed. You'll see here, devcert. It's running a VM that has a Docker engine in it that is the endpoint that I'm going to connect to from my Docker client. So that's now installed. Now, what I'm going to do is I'm going to pull 2 images, and these 2 images are going to take a little while to pull. So while we're doing that, we're going to examine a few more things. So I'm pulling WordPress and I'm pulling MySQL. And you know what? I need to cancel that because I'm pulling it to the wrong Docker. The first thing I need to do, having installed the VCH, is to actually point my Docker client at the thing that I've just installed. So what I need to do is I need to take these environment variables here that the Vic machine told me. And what do these do? But these are basically, let me just put this back in here. Copy that. There we go. So these environment variables do 3 things. They set up Tls Verification, because as an admin, when I install this VCH, I got some certificates as a result of installing the VCH, or I used my own certificates. But regardless, your way of authenticating as a tenant to this virtual container host is using these certificates. And so by setting these environment variables, I've basically told Docker client to use TLS verification, use these certificates, and this is what I'm going to point the Docker client to. So what am I doing now? I'm pulling down WordPress and I'm pulling down MySQL from Docker Hub. Okay, so we're starting out just pulling things down from Docker Hub. And what it's doing is it's extracting these images out to a data store. Now remember, we looked at the data stores that I have here. We have, as I mentioned, we have a vSAN data store and we have this iSCSI data store. And the iSCSI data store is running on an Intel NUC. Again, it's very lo-fi hardware that I'm working with here. So what is it doing? as I say, it's pulling these images down onto the image cache on my vSphere data store. And those images are being cached as VMDK snapshots. Okay? So as you see these things extracting, it's creating snapshots in that data store. And that's a really important thing to understand about Vic, is that when I'm at a Docker client and I'm talking to a Vic endpoint, I'm talking to vSphere. I'm not talking to Docker running in Linux, I'm talking to vSphere. So everything that I do from my Docker client controls vSphere. So Docker volume create creates a disk on a vSphere data store. Docker network creates a network that's in a port group, a vSphere port group. As an admin, I can assign port groups to you as a tenant to connect container workloads directly to, for example. So there's real deep integration between the Docker experience and the vSphere experience, and we're going to be seeing details of that in a second. Let me quickly show you the first hack, and I'm going to go to so you might want to note down my GitHub repository is Ben's Doings, corey/Ben's Doings, and a lot of the hacks that I'm going to be showing you are actually in this GitHub repository. The one that I just showed you, which looked like a script that was starting Vic Machine, is actually a thing that I did, which was born out of my own frustration with Vic Machine. It takes a lot of arguments, right? And you end up with a lot of scripts with the arguments that you give it. And so what I did is I created a JSON manifest parser for it. So the thing that we just deployed, if we go to devcert, which was the name of the VCH, and look at the config.json, you'll see that I've actually defined my virtual container host using JSON. So I've basically told it what the cluster is that I want to use, the minis cluster. I specified that I want a bridge network, which is called devcert, which is a port group. I specified that I'm going to be getting to the outside world on an external network called external network. I specified that I'm going to allow the containers to connect directly to this external network as a container network. And you'll see my volume stores here. I have a volume store that I've labeled backed up encrypted on the vSAN data store, and another volume store on my iSCSI data store. So there's a bunch of useful configuration in here, and what I can do is I can use, and actually that's bundled as a Docker image. So I can basically install Vic Machine from Docker using that little script that I showed you. And it just makes life really, really easy because all the commands, create, delete, inspect, debug, they just all parse out of that manifest. So if you want to know how to do that, Vic Machine in here will tell you all about how to do it. Now the most recent addition that I made to this is how to run an NFS server in Vic to actually export vSphere volume as a first-class citizen, but that is also read-write shared storage. Okay. Now, if we get time, I'll actually deploy that and show you how to do that at the end. But it's just worth noting that that's there. The reason I did that is because one of the new capabilities in Vic 1.2 is the ability to mount, to have a volume store that's an NFS mount. So you can actually make volumes available to containers as shared read-write storage from an NFS share, which is really, really cool. So let's take a step back. Let's see how our pull is coming on. Okay, our pull is completed. So now we have a MySQL and we have so if we type Docker images, so these two images now and all the layers for those images are on that data store that I asked them to download to. They're not in Linux. They're not using, they're not in a Linux VM. They're first-class citizens in a vSphere data store. And what I'm going to do now, let's say I do, let's create a couple of volumes. So if I go back to no, that's not what I wanted. If I go back to my thing here, okay, I'm going to create two volumes, and I'll show you what they're going to be. So the first volume I'm creating is on my vSAN data store. And the reason that you can tell that is because I've selected volume store equals and then the label that I gave it, which is backed up encrypted. And then the second volume I'm creating is on the default data store, which is on the iSCSI data store. Now again, remember, I'm the tenant and I'm doing this without any vSphere credentials. I'm creating disks on data stores without vSphere credentials because the admin has pre-authorized me to do this by installing the VCH. Right? The VCH is my self-provisioning endpoint that I, as a tenant, can get access to via those certificates that I showed you earlier on. So I've created 2 volumes. Now, I created my database data volume on my vSAN data store because that's really, really important to me. I want to make sure that that's encrypted, I want to make sure that it's replicated, and I want to have the option to back it up. And that volume is a first-class citizen on vSAN. The second volume I've put on my iSCSI data store because it has more space, because I've decided that's where it's going to go and because it makes for a good demo. So the next thing I'm going to do is I'm actually going to start. Now I keep going to this and it's not that. Okay. I'm going to start. I'm going to create a Docker network. So Docker network create dbnet, and if we do Docker network ls, you'll see in the Docker networks down here. Sorry, people, if you can't see because it's quite low. You'll see the external network, which is the port group that the vSphere admin specified, is now available as a Docker network. So I can connect Docker workloads directly to that external network, and then any traffic will go directly through the VNIC to the external network, and there's no NAT, there's no port mapping, there's no translation, there's no latency there. It just goes directly onto that network. The default bridge network is also a port group, and then this dbnet network that I've created is like a network within that port group. It's not strongly isolated. We do have the ability to do that with NSX, but in this particular case I'm not using NSX, so it's using IPAM segregation. So any container that I deploy into that network I've created, I can reference by name, and that's quite a convenient thing to be able to do. But the architecture I'm going for here is I want my database to be on a private network that's not accessible from the outside world. And I want my web container to be on this external network and get its own IP address, but also be on this private network so that it can talk to the database, okay? It's a kind of a classic setup where you're limiting what can see what's available to the outside world. So I've created my network, and now I'm going to create the MySQL container. Now I've used some environment variables here that I set earlier on in my shell, just to make sure that this works and just for ease of use. But just to run through this command line quickly, we're starting this database as a daemon. We're using the dbnet network that I mentioned. We're mapping the db data volume on vSAN into the container at var-lib MySQL. We're setting 1 vCPU, 2 gig of RAM, various passwords, and that's it, right? And then the container ID. So that's now started. And if we go back into vSphere, you will see, if we go to hosts and clusters and expand this out, there is my database. And if I look at the characteristics of my database, you'll see it's on that port group that we specified as the bridge network in our JSON configuration. So it's on the right network. It's not exposed externally. That's good. It's also, if we look at data stores, you'll see it's connected to the vSAN data store as well as the iSCSI data store, because the images that it's running from are on the iSCSI data store, the volume that it's writing to is on the vSAN data store. So that's why it's connected to those two things. So I hope you're starting to get the impression that I am controlling vSphere from my Docker client, right? That's the whole premise of what I'm doing here. And of course, I'm spinning up VMs that are very opinionated, right? These VMs behave just like containers, but these VMs that we're starting up don't have Docker Engine in them. It's not that we're starting up a VM with Docker in and then just starting a single container. We're starting the VM as a container, right? We're literally just booting the Docker image. That's what we're doing. So, the database is running. Let's get the WordPress running. Now, you can do this using Docker Compose, by the way. If I have time, I'll show you that. The reason I'm not doing this using Docker Compose is because it's easier to talk through it as we go along. So what have I done here? I've created my web container. I haven't started it though. The reason I haven't started it is because in Docker, if you want to put a container on multiple networks, you've got to create it and then attach it to the network and then start it. It's kind of convoluted, but that's just the way the Docker client works. So the next thing I'm going to do is I'm going to connect it to the private network so it can talk to the database. And then we're going to start it. Now remember I mentioned that you can refer to containers by name and you can resolve them by name. You'll notice here in this command line for the web container, if I can find that, where is it? somewhere in here. Yeah, no, not the name. I'm actually referencing the container name, the DB name. It's not that. It's DB, gosh, where is it? No, it should be there. Where am I configuring? Oh yes, here it is. WordPress DB host equals DB container name. Okay, so I'm setting an environment variable here that's telling WordPress you can resolve the database at the name of the container and port 3306. And because it's on this network, it can do that resolution because that's, again, how Docker works. So if we do Docker PS, here are my two containers running. Okay, so the Docker view of what's going on is completely consistent with the vSphere view of what's going on. So again, here you see the two containers. We have web. Now if we look at web and we look at the web networks, you'll see it's on external network as well as being on the DevCert port group, which is exactly what we wanted. So next step is to find out what the IP address of this thing is. So I can type docker inspect web, which is what we called our web container. You see the names on the right hand side there, and I'm going to just grep IPA, and that's going to show me the IP addresses. And you'll see it has two IP addresses, one on the private network, one on the external network. So now I can basically take this IP address and go to a Chrome, stick it in, and we should see WordPress. There we go, there's WordPress. Okay. So it's important to remember what I've done there, right? I've basically provisioned a database and WordPress to vSphere in 5 minutes, right? And this is one of the great things about Vic, is because the pulling and pushing from Docker image registries, and because the Docker image format is so pleasant to work with, the fact that we can now deploy VMs using the Docker image format, which is basically what this is a great step forward, because I can now deploy anything from Docker Hub to vSphere. You might not want to, right? And we're going to look at the vulnerability scanning in a minute that we've introduced in Vic 1.2, but that's the basic premise. So we're going to leave that running, and we're going to switch into, if I had longer, I would bring up Veeam and show you how we could back up those disks, but I'm sure you can imagine how you could see the vSAN data store and back those disks up. So let's move into the next step, which we're going to actually look at the management UI that comes with Vic. And I'm going to need to re-authenticate that. So you authenticate with the management UI in the same way as you authenticate with vSphere. And one of the changes in vSphere in Vic 1.2 is that all of the authentication is using the same single sign-on as vSphere. So all of the users and the roles in this Vic management appliance are users from vSphere, and you'll see I'm logged in currently as an administrator, using that same single sign-on. And you'll see, if you've seen the previous version, this is a little different. We've combined the registry and the management UI together, so they're not two separate things now. And what I'm going to do is I'm going to create a new project in this management UI, which you can imagine as just being like the thing for a team, like a project that a team is going to use to manage containers, manage images, and all that kind of thing. And what I want to show you with this is that we have this capability to have RBAC, to have vulnerability scanning, all the various features that you get with this built-in registry. And by the way, this is also deployed to vSAN, right? So all of the images on this OVA are being stored on a VMDK that's on vSAN, which again is a candidate for replication, backup, and encryption. So what I'm going to do is I'm going to create a new project. So I'm going to click into administration, click on new project, and I'm going to call this I'm going to call this VMworld 2017, and I'm going to give myself public access to the registry. Now that I've got this project, I need to configure it. So I'm going to add a user, and I'm going to add myself as a user. So bcorey@vsphere.local. That is another identity that I put into vSphere itself. I'm going to add myself as an administrator so I can do everything for this project. So there I am. Now, there's a few other options we have. If we switch over to configuration, and if I zoom down a little bit, you'll see the new vulnerability scanning feature. I can automatically scan images on every push. So anytime I push a Docker image to this repository, and we'll see that working, I can scan it with the vulnerability scanning. You'll see also there's content trust now as well. So we have notary support, so you can make sure that if you can set it so you can only deploy images that have been signed, so you know the provenance. So these are some useful security features that we've introduced. And hopefully we can now switch to this project. No, VMworld 2017. And let's just double check. Yep, that's right, one user, it's public. Okay, everything is good. So the very first thing I'm going to do is I'm going to push something to this repository. Now, what am I going to push? Well, the rest of my demo, at least as much as we're going to get through, is showing you Jenkins integration with Vic. Partly because it's Jenkins World at the moment going on in San Francisco, which is kind of funny. Partly because it's something I've been meaning to do for a long time, and partly because it really speaks the value of what Vic can do. Okay, so the first thing I'm going to do is take the Jenkins container from Docker Hub. So let's go into a different shell here. Now, this should be, this is just a regular Docker right here. And what I'm going to do is I'm going to do docker pull Jenkins/Jenkins:/LTS Alpine, which is the version of Jenkins that runs on Alpine. Now, I've already done this previously. It's already in my image cache. So what I want to do is I want to push this to my registry in Vic. Why do I want to do that? Well, the first reason I want to do that is because I want it to be scanned for vulnerabilities. And the second reason is because I don't want anyone deploying stuff straight out of Docker Hub. I want to make sure that stuff is scanned and in a private registry, and that I've blessed those images so that you can deploy them as and when you want to. So let's do that. Now, in order to push it, we need to tag it. So if we go to the repositories thing here, and we select push image, it helps us. It tells us what we need to do in order to tag it to push this image. So if we copy this and go back here, I'm going to do docker, it's just a docker tag. Can you guys see this okay? Is it too low down? Should I move it up a little? Is that better? Docker tag, the image name, which is, okay, that's what I'm going to need. So I'm going to take the image name here. So docker tag that. So that's the thing that I just pulled. So docker tag that. And then I'm going to call this new image, or at least the new tag for it, I'm going to call it Jenkins LTS Alpine. Okay. So I've now tagged that. This IP address is the IP address of the registry. VMworld 2017 is my project name. So that makes perfect sense. So what I'm going to do now is I'm going to do a docker push and push that to the registry. So docker push. Now, I've already authenticated with this registry. We have information online how to do that. That would have just been too painful to demo, just because it's just copying keys and all this kind of stuff. But just bear in mind, I skipped over that. Anytime I kind of skim over something, I want to make sure you at least know that I skimmed over it, right? So now it's pushed. Let's go and have a look and see what it tells us. So if we refresh this, okay, there is VMworld 2017 Jenkins, and okay, so it's scanned it for vulnerabilities. And it's shown that we have a high vulnerability. Okay, so wow, what am I going to do with that? I'm going to show you what we can do with that in a minute while Jenkins is deploying. So we're going to come back to that. But that's really helpful information for me, because if I click on this, it's basically showing me that the zlib library in Alpine, in this particular version of Alpine, has some high vulnerabilities in there. And what I can do is I can just click on that. It'll take me straight to the web. It'll tell me all about the vulnerability, all about, why is this a vulnerability? What are the problems? What version is it fixed in? But what's nice is that this also tells you what version it's fixed in too. So you can then go away and make updates if you need to. So let's go ahead and deploy this. And then while it's deploying, we'll look at what we can do about those vulnerabilities. And that's just a question of time saving. So now that I have this, I need to deploy it to something. So I'm going to add that virtual container host that I created as a container host. So I'm going to add it in here. So I'm going to call it test VCH. It's of type VCH. And I'm going to take the I need to get the environment variable that I set right at the start, which is the Docker host environment variable that basically is the address of the endpoint that I've been talking to. Okay, So I'm going to pass that in there, and then I need to specify the same certificate that the Docker client was using, which again is one thing that I did ahead of time, because again, it's just kind of a pain to do. So I'm going to save that, and that's going to now appear as a container host that I can deploy things to. Now, it will take a second just to tell me about itself. But yeah, now it's telling me, okay, you're already using up 8 gigabytes of memory in this container host, and it's not doing any CPU. Well, that is the WordPress that we're already running there. It's picked that up, and it's telling us that that's already running. So now we can talk to this container host from our management UI, and we can deploy things to it. So this is an alternate way to deploy things if you don't like using the command line. Personally, I prefer the command line, but if you would rather do it graphically, you can do it graphically, and this is how you would do it. Okay, so this is just an alternative way to achieve the same goal. So if we go to public repositories and we type in VMworld 2017, so we can search for our image. There it is. Okay, VMworld 2017/Jenkins. There's my image. So I'm going to provision that image to that virtual container host. So I should be able to find my tag, which is LTS Alpine. That's right there. Now I'm going to go through and just configure a couple of things. In fact, I'm going to save it as a template so that when I make configuration changes, I can go back to them and they'll still be there, and I can just keep changing it. So I'm going to do a couple of things here. I'm going to set a network port. I'm going to map port 8888 to 8080 so that we can talk to this container on port 8888. Now that's using port mapping, if those of you are familiar with that, which is a means of exporting a port in the container to the IP address of the container's host, in which in this case it's the VM that we're talking to. You'll see how that works in a second. So I've set the ports. I'm going to go to environment. In fact, I'm going to go to policy, and I'm going to say I want to give this 4 gigabytes, and I'm going to go to environment, and there's a funny little option I have to set, which is tinny sub reaper, just a Jenkins quirk. We'll save that. Now, if I've not forgotten anything, which I hope I haven't, so we've got network, storage. So in terms of storage, Jenkins is just going to create a default anonymous volume. For the purpose of this demo, we don't care to set a volume necessarily, but again, it's going to create it on that default volume store, which is that iSCSI data store. So let's save that and let's provision that. So now this is going to cause that virtual container host to pull down that Jenkins LTS image from this private registry instead of pulling it down from Docker Hub. And that's going to take it a couple of minutes. And while it's doing that, let's talk about these vulnerabilities and what we can do about it. So if we go back to our registry, let's say that we look at this and we go, okay, well, maybe the problem here is Alpine. Maybe I shouldn't have chosen Alpine because I've heard that, oh gosh, is it what license? I don't know. Maybe Alpine's bad. Maybe I'll just get the regular Jenkins image and do that instead. So let's do that. So if we go back to where we were, and let's do Docker pull Jenkins, just pull the regular Jenkins image. Again, I already have it. And then let's tag that in the same way as we did previously. So Docker tag Jenkins, and we'll tag this just without, we'll just tag this without a tag, without latest. Then we'll do Docker push, and we'll push that. Now, this is Debian based. So, and it has Java in it, it has various other things in it. You can go to Docker Hub and you can look at the Docker file and you can look at exactly what is in this image and what it's based off of. But actually going to Docker Hub and trying to trace all the way back through the image stack is really painful. It's not particularly easy to do, it's not particularly easy to visualize. So one of the nice things about these vulnerability scanning capabilities, and by the way, this is built off the Claire project from CoreOS. One of the nice things about those capabilities is you don't have to go all the way back up that image tree. You can, the vulnerability scanning will figure it out for you. Okay, so let's refresh this now. Now you'll see we have 2 tags, and this is Jenkins latest. Wow, okay, that's even worse. All right, so we have, let's just order these by severity. We have 8 high vulnerabilities, and each one of them is in a different package. glibc, ncursors, shadow, SQLite, and so And the thing that surprised me about this, honestly, when I was preparing this demo, is that almost none of these are actually upgradable in this version of Debian, right? You actually need to go to the next version of Debian to be able to get these packages, upgraded. And that surprised me. So maybe I do this, and maybe I go, oh, okay, maybe Alpine is better. And it's interesting because Alpine has less packages in it. You'll see when we scanned it, it shows overall there's less packages. And so in some respects, there's an argument for having less packages in terms of having a lower attack surface and potentially less vulnerabilities, and that's an interesting perspective. So what I'm going to do is I'm going to go back to Alpine, and I'm going to fix the vulnerabilities in Alpine, and then we can all cheer and feel good about ourselves. So I'm going to do that, and it's pretty straightforward. What I'm going to do is I'm just going to make muckdeer temp. It exists, all right. Muckdeer build temp. All right. Build, no, not build. Temp. Okay. I'm going to create a Docker file. And I'm going to do from Jenkins LTS Alpine. And the thing I'm going to run is I'm going to run apk update and then apk upgrade. And only because I've done this before and I know that it will fail, I have to add user root in order to be able to do that, because in the Jenkins image, Jenkins is the default user, and then I need to set the user back to Jenkins. So run that. So now I can do docker build -t. I'm going to call it something meaningful. So I'm just going to copy this. I'm going to call it Jenkins LTS Alpine upgrade. Grade. Okay. And I just need to add a dot to tell it to build in this current directory. Okay. It's now built this. Now, this was actually in my cache from having done it before, so you're not going to see too much pretty build output, but trust me, it's run APK, it's done the update, it's done the upgrade. So now I'm going to push this thing that I just built to my registry. Okay? And you'll notice that pretty much all of it already exists because I've built it off the previous one. It doesn't have to push everything all over again. It's only push my little change. And if we refresh that, we should see, hooray, there we go. I have a completely clean Jenkins now with no vulnerabilities in it that's completely green. Okay? So hopefully that's a helpful illustration of from an admin perspective, not only why having a private registry is good, and a private registry that I can control and I can control access to, but also being able to bless images and making sure that I'm deploying things that I'm happy with, right, and that I'm comfortable with. So if we go back to containers, okay, praise the Lord. Our Jenkins container is running. Everything is fine. I didn't misconfigure anything. So let's have a look and see what we can do with this. So I can click on the container and it will show me some information. It will show me the CPU it's using, it will show me the memory it's using, and it will also show me the logs, which is a really, really nice feature of this UI. And the thing I actually need from the logs, which is really important to deploy Jenkins, is it sets up a temporary admin password that we're going to need as soon as we get Jenkins up. So what is the address for Jenkins? Well, the address is basically going to be this. Remember we asked it to be on port 8888. So I'm going to open this up, port 8888, and yes, there we go, we have Jenkins. So let's go back here and let's copy this password because that's what it needs. So we'll copy the administrator password in here, and hopefully it'll think about it. Great. Awesome. So now we can go ahead and install the suggested plugins for Jenkins. This will it doesn't take too long, it takes about a minute or so. Now Jenkins has a lot of plugins, and part of my journey with configuring Jenkins with Vic was just learning that there's almost more plugins around Docker than I have time to investigate. So what I've done in terms of this particular demo is I've just gone with the default CloudBees plugin that they have. I also haven't yet had time to write this stuff up, but in a week or two, I'm hoping to write up some of this work I've done with Jenkins in my GitHub so that you can go and see and experiment with it and play with it. What I'm going to demo in Jenkins, obviously we've provisioned Jenkins in Vic, which is cool, but I'm also going to show how you can use Vic as a cloud for Jenkins slaves. So you can basically run jobs in Jenkins and it will just kick off container VMs using a virtual container host and just run jobs on those container VMs, and then it will automatically just get rid of them again. So it really means that you can use your vSphere compute capacity as completely ephemeral compute, very much in the kind of in the sort of cloud vein. So admin, my password is going to be admin. My full name is admin. And my email address is admin@admin.com. Okay. Yes. Okay. So we have Jenkins running, and we can start using Jenkins. So the next step is going to be to add in the plugin that I want. So I'm going to go to Manage Jenkins. I'm going to zoom in a little bit again because I know that this is slightly low resolution, or high resolution. Actually, your eyes are low resolution. So hit Configure Jenkins. Here we go. So actually, no, that was not what I wanted to go to. I wanted to go to Manage Plugins first. So I'm going to go and look for the Docker plugins that are available. If I type Docker here, I'm going to select this Docker plugin, and I'm going to install without restart. So it's just going to install that plugin. Now that plugin is going to allow me to basically talk to Docker as if it were an IaaS API, basically. That's great, that's working. So that's now installed. So if we go back here to our Manage Jenkins. So now I'm going to configure a Vic cloud. Now what I'm actually going to do is I'm going to install a new VCH for that. For no reason other than you may well want this to be isolated and maybe in a different place, maybe using cheaper storage, maybe using whatever. So in this particular example, I'm going to run Vic machine. I'm going to run version 1.1.1 dev ESX, which is going to install this to a single ESX host rather than to a vSphere cluster, and create. And that didn't work because I'm in the wrong directory. Okay. Okay, so this is going to do exactly what you just saw, but this is just installing to a single ESX host. And the single ESX host is just has an SSD data store. It's really cheap storage. It's fast. It's really fast. It's faster than the shared data stores are because there's a lot less in the way. So let's set this export Docker host. Okay, so this is our Docker host for this. Now you'll notice I haven't set any credentials for this. That's a bit naughty. It just makes it simpler for now. So I'm connected. If I type Docker info, by the way, it'll give me information about the thing that I'm connected to. But this is running on my my Intel NUC that's also hosting the iSCSI FreeNAS server. So that's running. So now what I'm going to do is I'm going to take that IP address. Actually, while I'm doing that, I'm just going to do docker pull ivaga Jenkins slave. Now this image is an image on Docker Hub, and it's very basic. It has SSHD in it, it has Java in it, it operates as a Jenkins slave. It's just nice to know that Vic will just run this just straight out of Docker Hub and it just does the right thing. You may want to consider adding more security and vulnerability scanning and everything else, but for argument's sake, this works just fine. So what I'm going to do is I'm going to go into Jenkins and I'm now going to configure Jenkins to talk to this ESX host. So the configuration in Jenkins that I need to do is come all the way down the bottom here and you see add a new cloud down the bottom there. And it gives me the option to add a Docker cloud. Now what does cloud mean in this context? Well, cloud basically is just IaaS API, just a means of spinning up slaves, right? And in this case, if you installed regular Docker, it would spin up slaves as containers within a single VM. With Vic, what it's going to do is it's going to spin up each slave as a VM. So to the name, I'm going to put test VCH. The Docker URL is the thing that we just saw, which I think I copied. Yep, now I need to just remove that and type TCP. Okay, so that's the Docker URL. We didn't set any credentials, so there's no credentials to set. And now I can test the connection to that VCH. And it should, yeah, we go. It's good. We have a connection. It's version 1.1.1, API version 1.25. So what am I going to do now? Well, within this cloud, I can now basically add things called templates. And a template basically is a means of having different kinds of Docker image for different kinds of builds or tests or jobs, right? So I'm going to actually, if we get to it, I'm going to add 2, but for now we're just going to keep it to 1. I'm going to add in that Evaga/Jenkins slave, which is the name of the Docker image that I want. There's no funky settings that I need to add to that, as far as I can remember. Instance capacity is how many of those containers should be running at any one time. I'm going to put in 5. Labels, I'm going to give this a label of shell because I want this to be for just things that are running, in a bash shell, for example. Usage is interesting. I'm just going to keep that set to use as much as possible. The launch and the experimental options give you this, which is even better. So you can basically say to it, start the container up, and the moment you're done with the build, kill it, delete it, which is this one here. Or you can say to it, keep it online as long as possible, or you can say to it, keep it online for a certain period of time. So I can say, keep it online for 10 minutes, but if it's not used for 10 minutes, just get rid of it. So again, remember, this is Jenkins controlling vSphere to spin up VMs to do build jobs. And it will just control the scheduling of those VMs as it feels it needs to. Number of executors, let's say 5, because that means we can actually run 5 builds in this VM or 5 things in this VM. And we need to add credentials. We need to add some credentials to be able to log into this because it's using SSH as the launcher. So if we add some credentials, the Evaga image uses Jenkins. It's imaginative. Okay. So we should be good now. So we've added in these details. So let's save that. Okay, we've added in the details, and hopefully this is going to work. Now what I'm going to do is I'm actually going to go and run this manually in this VCH just so you can see how it works. If we do Docker images, that's not the right window. Sorry about that. So Docker images, there you see Evaga Jenkins slave. Let's just run that. So Docker run -d and then -p. Let's give it 7777 as a port. And I'm going to map it to port 22 because we're talking to it over SSH. So Evaga Jenkins slave. And that should be everything that I need. Okay, so I'm going to run that. So that should be running. Okay, so Docker PS. We see it running with the ports. Now, if I do SSH Jenkins at, and then this IP address, and then -p 7777. Good. That's what I wanted. So I verified that I can actually SSH into this thing, this is what Jenkins is going to do. It's going to SSH into this with those credentials, use Java to set up its agent. The agent's going to talk back to Jenkins, and it's going to work that way. So let's do Docker stop. Let's just stop this one. Docker stop to BB. And what did I get wrong there? It's 2BD. Okay. That's just the first 3 of the container ID, by the way, in case you're wondering what that is. You can shorten it, which is useful. So let's create a new Jenkins job. So let's click on Create New Jobs. Let's create a freestyle project. We're going to call it Hello World. Of course, every container demo is always Hello World, right? It's never anything more complex than that. So what I'm going to do is I'm going to basically say, run this job on any node with the label shell, which is what we put in earlier. And it's telling us label shell is serviced by no nodes in one cloud, which is good. It's recognized that. And then down here, I'm going to add a build step, and I'm just going to do execute shell. And in the command, I'm just going to put echo hello VMworld. Okay. So it's pretty trivial. Save that, and I now have a job. Okay, I have a Hello World job. So everything should be in place for this to work, and this is really where we need to cross our fingers. So I'm going to schedule this build, and it's surprising how long it takes Jenkins to wake up and get its agent installed and get things running, but we can actually look at what's going on as it does it. So if we go back to our window here, and if we do Docker PS, yes, you see it started the slave. So there's a slave running, and now what it's doing is it's SSHing into that slave, is installing its agent, which is a Java agent, and as soon as it's done that, we should see it appear as an executor in Jenkins. Now, while we're waiting for that, here's another cool thing you can do with Vic. In 1.2, we introduced the ability to do Docker exec and Docker CP, and Docker exec with it being interactive as well. And this is huge for VMs. Let me explain why. When you run a container should just be one thing, right? It should be Jenkins, or it should be WordPress, whatever it is that you're running, it should be one thing. Now, let's say you want to get a shell into that container. You shouldn't have to put SSHD in that Jenkins container, because that's such a mixing of it's not what it's for, right? That should be an infrastructure capability. Let's say you want to have an NFS mount in that container. Again, you shouldn't have to have the NFS client libraries loaded in that container in order to have an NFS mount, which is why we have this NFS volume support. These things should be at a layer below and should be made available to the container without needing those other capabilities. So what this means is I can type docker exec -it and then the container ID and then /bin/bash. I installed version 1.1.1 that doesn't have exec support in it. At least it gave me a helpful message. What we'll do is we will go back to our other version, which is 1.2, and we'll do the same thing. Docker ps. So here's let's get a shell into our Jenkins. So if we do docker exec -it and then the ID of our Jenkins, and then /bin/bash. Yes. Okay. So what we've done is from the Docker client, we've now got a shell into this VM without SSHD being in there, right? Which is really, really cool. And it's not just the shell capability. I could basically run it without the shell, and I could just run ps-ef, for example, and just see what's running. So ps-ef, and it will run that and give me the output, right? So this is really, really useful because you've never been able to do this with a VM. And because Docker is like opinionated and gives us these capabilities, we've been able to do that. The same for Docker CP. So again, if you want to copy data in and out of a VM, do you want to have an SCP capability installed there? For security reasons, maybe you don't, but also, as I say, for other reasons, you may not want to have that. So now we can copy stuff in and out of the container without needing to have SSHD in there, without needing to have SCP. We can do the same trick. So let's go back and look at how this is. This clearly hasn't worked, and this is the one. Yeah, it's still waiting for an executor. I've almost certainly configured something badly. Let's go and debug this. So, because we do have a few minutes left, and if I really can't debug this, we'll switch over to looking at the NFS thing. But I'm determined to make this work. So, if we look at, it's interesting. It's actually, no, this is the wrong window. Docker ps. Okay, this is the slave that it started. Let's just double check that we can SSH into this slave, because I was seeing some weird network glitches when I was practicing this that I couldn't explain. So let's do 32.768, 32.768. Yeah, this is really odd. This is really odd. This is why it's failed to install its daemon, because, and I don't know why this is. I need to investigate this, because this is something weird on our network side. So yeah, that's really annoying. You know what I'm going to do? I'm going to delete this. 1 second. I'm going to make this work. Let's stop this. 77. Let's delete it. So I don't want to delete that one. I want to delete 1.1.1 dev esx delete. And I know this isn't a bug in 1.2, and this is why I'm using 1.1.1, because I wanted to. This has always worked for me, and it's just weird. Okay, so we'll recreate that. And re-pull it. Well, this will pull it. We don't need to pull it explicitly. This will pull it anyway. So let's stop that. Let's go back here. Let's go back here. Okay, so that's stopped. So now that this is running again, it's the same IP address, so we don't have to change anything. Okay, let's try rerunning this. So this Jenkins will now pull that image. It will run the image. Let's leave that and just come back to this in a second. Just verify that it's working. Let's go through the NFS server demo, because I think that's pretty cool. And then we'll come back to this and just verify that that's worked. We are 10 minutes away from the end. By the way, I wasn't planning to leave a lot of time for questions because I feel like we're covering a lot of things here. Feel free to come and ask questions of me at the end, though. I'm happy to stick around for as long as you would like. So let's go back to our original virtual container host. Remember the one that's installed to vSAN and the vSphere cluster. So if we do docker ps, we're seeing our containers. What I'm going to do is I'm going to do docker volume create, and I'm going to do -- opt, and the data store, the volume store that I'm going to use is, now what did I call it? I called it backed up encrypted something or other, didn't I? And it's not there, it's here. I called it backed up encrypted. Now, I could have found that out from typing docker info, but I'm already in the middle of typing. So volume store equals backed up encrypted, and then I'm going to just do opt capacity equals 5G. So I'm creating a what's wrong with that? Oh, I didn't give it a name. Docker volume create, let's call it NFS vol. And what did I get wrong there? Docker create -- opt volume store. What did I get wrong there? It doesn't. What did I get? Oh, you know what? The name needs to be at the end. Yep, the name needs to be at the end. Helpful error message. All right. So let's go to the end. Oops, no, I don't want that. Why can I not? Oh, Control E. There we go. Okay. So I'm going to call it NFS vol. This is why I cut and paste, because this is what did I get wrong? Oh, -- oh, sorry, -- opt. Yep, you're right. Hooray. Okay, thank you for helping me. So I've now created a 5 GB disk on the vSAN data store. That's what I've just done. All right. So docker volume ls will show me that. And in fact, I can see the volumes in here as well. If I go to here and to click on networks volumes, I see the volumes in here as well. Okay, I need to refresh this, but the volume should show up in there. It should show up in there. It will eventually show up in there. All right, so I have my NFS vol. So I'm going to go back to my my GitHub page, and I'm going to show you how simple it is to run this NFS server. So what I'm going to do is I'm going to use this version of the command here, and if we cut and paste that in, so let's just make sure this is right. So docker run, I'm going to run it as a daemon. I'm going to map NFS vol to /mount /NFS vol in the container. So I'm mounting this volume into the container, which is an NFS server. I'm putting it on the external network so it will get its own IP address. I'm specifying the ports that need to be open. Another feature in vSphere 1.2 is we have firewall configuration on the container networks. So you have to explicitly open ports on the container networks in order to be able to have them visible. There's other ways we can configure that firewall. And then I basically told the container that the folder I want to export is /NFS vol, mount /NFS vol, and this is the name of the image. So let's run that. It's going to have to pull that down from Docker Hub. While it's doing that, let's go back to Jenkins and see if we've had more joy with this. Yes. Oh, well, okay. It appears to have created an agent, but the agent is offline for some reason. See log for more details. Yes, it just couldn't log in. That's odd. That's really frustrating. There will be a video of this, and in the video this will work. And to be fair, this has gone pretty well so far. This is the one thing that I didn't have time to figure out last night what was going on with my network on this ESX host. It's odd. It's really odd. Okay, let's park that because we're almost at time. And as I say, I promise I will do a video of this, and I promise in the video it will work. The second thing I was going to show you was adding a second image to that cloud that that is a nested Docker image. So you can get Vic to deploy a regular Docker host as a container. And then you can have that do Docker builds. So you can basically have this cloud of VMs that have Docker running in them that you can use to create images. And the final sort of denouement at the end of the, what will be the video will be this kind of a full workflow of build, test, deploy, where we're using nested Docker to build, we're using Vic to test, and then we're deploying it to Vic. So, with the Jenkins integration, that should be really seamless and really straightforward. So now that we have this NFS server running, what I'm going to do for the final trick, I shouldn't call these tricks. I'm going to delete that this VCH that we had running. I'm going to Docker stop. I'm going to stop that Jenkins slave. What I'm going to do is delete that. And what I'm going to do is this NFS share that I've just created, I'm going to add as a volume store to this new VCH so that I can then create volumes for containers on that NFS share. What I need to do is I need to edit the configuration for this. So if we go into dev/esx and then config, you'll see this is my config for my ESX VCH. So what I'm going to do is I'm going to add in a volume store here. And the volume store I'm going to add in is, actually, you know what, I'm going to cheat a little bit and just cut and paste out of here, because this is going to be way, way easier. So, because I tell you how to do it in here, and so often I refer to my own documentation for reminding myself how to do things. So, yeah, that's right. Okay. So I'm going to copy this out of here, and I'm going to put it into here. So this is how we refer to an NFS volume store. So we basically have the IP address of the NFS server, the mount point, and then user ID, group ID, and the actual label for that volume store that it's going to be exposed as in the VCH. So I need to make sure this IP address is right, because it almost certainly won't be. So if we do docker ps, you'll see my NFS server is this container here, 09B. So we do docker inspect 09B grep IPA. There is the IP address of my NFS server. So again, this is an NFS server that I deployed in Vic, exporting that vSAN disk. And I'm going to add that into this configuration. So let me just change this. So this volume store is going to be called NFS store. Now let's just double check. I called it, the mount was called MNT NFS vol, and that's what it said to MNT NFS vol. Okay, this should work. So let's do Vic machine. Now we need to use the latest version because that has the support for this in. So master dev esx create, and I need to be in this folder here. Okay, so this is now creating a new virtual container host that is going to have that NFS share as a volume store. Now, another feature we introduced in Vic 1.2 is the ability to reconfigure a virtual container host after it's been deployed, resetting passwords, creating new volume stores, making modifications. So you don't have to uninstall it and reinstall it. You can reconfigure it to do that. And actually, a cool trick is you can use reconfigure to expose an NFS share as a volume store in the same VCH, which is actually kind of a neat thing to be able to do. So let's do docker info. We should see the volume store in here. We do, volume stores. You see here, default and NFS store. So the last thing I'm going to show you is, well, what can I do with this now? So if I do docker volume create NFS share 1 and -- opt volume store, I'm doing this wrong again, right? It's got to be opt first. Docker create -- opt volume store equals NFS store, and then I'm going to call it NFS share 1. Excellent. So I now have a new volume. If I do docker volume ls, I should see NFS share 1 in there. It is there. So now let's do docker run dash D. Let's do docker run dash D Debian, and then I'm going to run sleep in this. Just get it to sleep, just that it sort of runs. And I'm going to mount the volume. So -v NFS share 1. I'm going to mount it to /data. That needs that there. So that should work. Okay, so it's going to pull Debian down because this is a new VCH. We deleted the image cache when we deleted it. So now I have Debian. We're 1 minute away from the end of the talk. So this this should be just the right amount of time. So now that's running. And I'm going to run a second one, exactly the same, which should run pretty fast. There we go. So these are 2 VMs running with this NFS share mounted to /data. So if we do docker ps, we'll see them there. So now if I do docker exec, and then the first container ID 044, and I do touch /data/foo, using our exec support to create a file on that NFS share. Then if I do docker exec 0e42 ls/data, there it is. So I can see it from the other container. All right. I'm bang on time. I'm really glad that I got through as much as I was able to. Thank you for sticking with me. As I say, I promise to make a video of this so that you can examine it in more detail and put that online. I hope this was informative and enjoyable, and do come and chat to me afterwards. Thank you.